Hello students, welcome to IMS Academy. In this particular session, we are going to discuss the memory-based questions regarding digital circuit subject, which are asked in the GATE 2025 electrical and instrumentation papers. So whatever the questions currently we are discussing, definitely these questions are going to helpful for the GATE 2025 EC aspirants. Okay. So in this particular session, we are going to cover all the questions whichever we have received from our students regarding digital circuit subject from these two papers. Okay, right. And whoever visiting our YouTube channel very first time, kindly subscribe our YouTube channel, and all of you like and share this video link with all of your friends, so that whoever going to write GATE 25 exam in EC paper, definitely all those students are getting maximum benefit from this particular session. Okay. Yeah. And whoever not yet joined our Telegram channel, all of you can kindly join our Telegram channel. It is free for everyone. So the link is already provided in the description of this particular video. So all these benefits you will be getting, right? So in our Telegram channel, whatever the upcoming live sessions we are conducting regarding that particular lectures, schedules, everything you will be getting update in this particular Telegram group, and you will be getting the PDFs, whatever we are discussing on this particular digital board during the live class. That particular PDF we will be sharing in this particular Telegram group, and you will be getting all the important updates regarding seminars or webinars, and you are getting all the job notifications, and not the least, on daily basis you are getting the quiz question, so you people can actively participate and you can check your knowledge. Okay, so all these benefits you are getting for free of cost. All of you can kindly join our Telegram channel, and all of you can share this valuable information with all of your friends as well. Okay, right. So now we are going to start regarding the memory based questions of digital circuit subject, which are asked in the instrumentation and electrical, both the papers, in the 2025 GATE exam. Okay, so this is a question regarding number systems chapter regarding 2's complement form. So in this particular question, they have given two numbers, decimal numbers, both are decimal and both are same number, 5. Okay, 5 plus 5 you have to add. Whatever the answer you are getting, that particular answer they have considered in the 2's complement form. Okay, so whatever the resultant answer you got, for that resultant answer, if you are considering the 2's complement form, then the corresponding decimal equivalent. This is a very, very interesting question. The way they have framed the question is very interesting. Okay, I hope all of you know regarding, yeah, 5 plus 5 is nothing but what? 10. 5 plus 5 is nothing but 10. Okay, so regarding 10, when you represent in unsigned binary, you are getting 1010. So with respect to unsigned binary, you are having 1010. Now what they have mentioned, whatever the binary number you got, now that particular binary number, if you have considered in the 2's complement form, now for this they are asking the equivalent decimal number. Okay, this is a very, very interesting question. Instead of, in general, they will be giving in the combination of ones and zeros, and in the question they will specify that that particular number is already represented in 2's complement form. You have to find out the corresponding decimal equivalent. But in this question they made twist. What they have done, whatever they have given two decimal numbers, addition operation, whatever the resultant number you are getting as per unsigned notation, now that particular number you consider in the 2's complement form. If you consider this one in the 2's complement form, now they are asking the equivalent decimal number. Okay, so when you are having any number which is represented already in 2's complement form, just observe the sign bit. Here sign bit is 1, that means it is a negative number. Okay, now you can put the positional weights in powers of 2. 2 power 0, 2 power 1, 2 square, 2 cube. Whether you are having sign bit 0 or sign bit 1, irrespective of that, the first step you can put the positional weights in powers of 2. Now, suppose if the sign bit is 0, you can consider the respective positional weight as positive. But here sign bit is 1, that means respective positional weight you can consider negative. After that, wherever ones are there, just add the respective positional weights, that's all. Wherever ones are there, just add the respective positional weights. So in this particular example, you are getting minus 2 cube is nothing but minus 8, plus 2 power 1 is nothing but 2. So from here you are getting minus 6. This is a very, very interesting question. So answer for this question is option B. Option B is the correct answer. Okay. minus 6 base 10. Okay, I hope many of you solved this question correctly. Okay, right, next question. This is the question asked in instrumentation 2025. Okay, in this particular question they have given one Boolean function. They are asking the corresponding complement form. Whatever the expression they have given, for that you have to apply complement, and you can observe the choices. You are having the choices in the simplified form. So I hope whenever you are supposed to use De Morgan's law for find the complement of given function, before applying De Morgan's law, just observe whether you can do simplification or not for the given function. If simplification possible, first do it, and then if required you can use De Morgan's law. Okay, so for this particular question, you can take a bar as common. On the right hand side you can take a bar as common. Okay, so if you take a bar as common, then you are having a bar into a bar. If you take common, then you are getting b bar plus c bar. Okay, now a bar I am keeping as it is. B bar plus c bar we can write it as bc whole bar by using De Morgan's law. Bc whole bar is nothing but b bar plus c bar, right? Now this is the function you got in the simplified form. Now you are supposed to calculate x bar, or otherwise before that you can write like this also. Okay, for this question, just like here, see, just observe here, you are having, like, you can treat like this, x1 bar and x2 bar. That one you can write as x1 plus x2 whole bar. Here x1 is nothing but a, x2 is nothing but bc, and whole bar. Very simple. A plus bc whole bar is nothing but a bar and then bc bar. Okay, just for reference here I am mentioning whatever the formulas here I have used, like x1 and x2 whole bar. Suppose if you are having like this, by using De Morgan's law we can write it as x1 bar plus x2 bar. Okay, next another one, we are having like x1 plus x2 whole bar is nothing but x1 bar and x2 bar. Okay, so just observe here, you are having like this format, we have written in this form, correct? Now here you are having, if you are having like this, we can write like this. Now this expression was present like that format. Okay, here x1 is nothing but a, x2 is nothing but bc. Now this is x, whatever the right hand side expression is there, that is nothing but x. Now they have asked what? X bar. Okay, so x bar, x is already presented in the complement form, x bar, that means you are performing once again complement, so that means normal function. That's all. See, on both sides if you perform complement, 2 times complement means normal function. So that means you are getting a plus bc, that is option D. Option D is the correct answer. Okay. Yeah. Next question, this is a very, very interesting question. This is a question asked in GATE EE 2025, right? In this part, this is the question they have framed based on 2 chapters. Whatever the given function is there, if you observe the given function is in which form? Pi capital M. Yes or no? Because here if you observe in this particular overall function, it is a function of 4 variables, and in each and every term you are having 4 literals, and among the literals logical OR operation is there. That means whatever the individual terms you are having, those are nothing but max terms. Max terms multiplied together, that means pi capital M. Okay. See, for this particular question, many of you might have solved this question. Since the given function is pi capital M, okay, you might have considered 4 variable K-map, and in the respective max term positions you might have put zeros, and then you have done the grouping. Of course, definitely from there also you will be getting the same answer. Okay, so whatever the given pi capital M is there, with the help of K-map, when you do the simplification, you are getting one POS form in general. Okay, fine. See, that is one method you can do it. Okay, by using K-map you can do it. This is one method. Okay, so just for reference here I mentioned method 1. but this method as of now I am not solving because many of you might have solved during the GATE exam this method only. In fact, whoever might have seen this particular question, when they want to answer this particular question, many of you might have solved by using K-map. Okay, but now I am going to discuss the easiest method without using K-map. Without using K-map, how we can solve this particular question, that method I am going to discuss now. In fact, that is a method in general in our regular classes we used to cover. Okay, regarding Boolean algebra, you are having many laws of Boolean algebra. Among those laws of Boolean algebra, one of the law is distributive law. Okay, so regarding distributive law, many of you know LHS to RHS, but wherever required, if you want, you can apply distributive law RHS to LHS also. Okay, just for reference, here I am mentioning. Yeah, regarding distributive law I am just mentioning. Regarding distributive law, you know the formula, this one, x plus yz, we can write it as x plus y into x plus z. X plus y into x plus z. This is from LHS to RHS. Okay, now when you are saying LHS equal to RHS, obviously RHS equal to LHS. X plus y into x plus z. Okay, if you are having this expression, okay, you can write this expression in one step. See, when you are saying LHS, RHS are same, definitely RHS and LHS both are same, correct? Now, what you have to do, in both the terms, whichever part is common, just copy that one as it is. Here x plus is same. In both the expressions, x plus is same. Copy. Now, whatever the leftover variables are there, just perform logical AND operation. Logical AND operation. So, in this way, regarding distributive law, RHS to LHS, okay, with the help of this logic, without doing further simplification, in one step, you can write the LHS term. Okay, so many of you, whoever attended our classes, by this time you are familiar where to apply distributive law LHS to RHS, RHS to LHS. Whoever applied this particular distributive law RHS to LHS, definitely they could have saved time during the actual GATE exam time. Okay, yeah. So now that particular logic we can apply for this particular equation. Just observe here, first two terms you can observe, u bar plus v bar plus w bar. U bar plus v bar plus w bar plus, okay, up to there in these two brackets it is same. Yes or no? Right. So now you can consider whatever the portion, it is common in both the brackets, just like here, x plus something, we have written x plus, correct? Okay. So in the similar way, here you can write, from first two brackets, you can write f equal to u bar plus v bar plus w bar plus okay, just for understanding I am writing one more step, but otherwise we could have saved time. Okay, just for understanding only I am writing one more step. See, in both the brackets, whichever part is common, we have written up to there. Now what is the next step? Whatever the leftover variables are there, among those two you have to perform logical AND, right? Now just observe here, x bar and then x. Logical OR you have to do x bar and x. Okay, so this is the term you are getting after doing the simplification of first two brackets by using distributive law RHS to LHS. Okay, similarly you can observe these two brackets. These two brackets, if you observe, this portion is common, yes or no? U bar plus v plus w bar. In both the brackets it is same. U bar plus v plus w bar. Now up to here, whichever part is common, we have copied. Now among the leftover variables, logical AND, x bar into x. Okay, this is the method 2. Just for reference, here I am mentioning this is the method 2. Okay, right, fine. Now just for understanding purpose only we have written, but you can save the time. You don't need to write this much. Just by observation here, x bar into x is 0. Okay, only this much portion you can write in both the brackets. Okay, whatever the common portion is there, that much, because when you perform leftover variables logic line, you are getting 0. Okay, now this part is 0 and similarly this part is 0. Okay, now from here you are getting u bar plus v bar plus w bar, then second bracket you are having u bar plus v plus w bar. Okay, just for understanding purpose I am writing one more step, but otherwise you can visualize from this step only. Okay, just for understanding purpose I am writing like this: u bar plus w bar plus v bar. Okay, I have just kept u bar plus w bar one side and then v bar other side. Okay, similarly here also u bar plus w bar we can keep one side and then you can keep v at last. Why I kept like this? Because once again you can apply distribute law RHS to LHS, that is the only purpose. Okay, right. So now you can observe in both the brackets, u bar plus w bar, u bar plus w bar plus, up to there it is common, you can copy. Now u bar plus w bar, then what you are getting? V bar into v is nothing but 0. V bar into v is nothing but 0. So from here you are getting this term anyway is 0. Now you are getting these two terms. That means u bar plus w bar. U bar plus w bar. That's all. See, for understanding purpose I have written this many steps, but once if you know distribute law RHS to LHS, just by observation first two brackets you can write this one. Similarly from last two brackets you can write like this. Okay, only this one step you have written. Okay, just for reference I am putting the tick mark, so that how easily or how you could have solved this question in less time. Okay, with minimal calculation, with minimal using pen and paper during the GATE exam. How easily you could have solved this question. In fact, you could have saved the time while solving this particular question. Okay, at least this thought process will helpful for the GATE 2025 EC aspirants. Okay, whenever you are getting the question seems to be like lengthy question or complicated, but once if you know the basics and fundamental, wherever you can apply, definitely with the help of that you can get the answer quickly. Okay, I am repeating once again. So from this given expression, if you are able to apply distribute law RHS to LHS, directly in one step you can write this one, and after that if you observe further common terms, u bar plus w bar, u bar plus w bar is common part that you can write, and then whatever the variable is differed, here v bar and v logic line when you perform 0. That's all. So that means only two steps. Now all of you can cross check, especially the students whoever might have solved this question by using K-map. Just you people can evaluate how much time you could have taken, and once if you know this particular shortcut method, even though you don't know earlier, but at least you come to know with the help of this session. Now just cross check how much time you really took for writing these two steps. That's all. Now you people can decide like how to solve the digital question in the GATE exam. Wherever there is a possibility, try to solve in the less time by using the shortcut. Shortcuts, it won't came all of a sudden, but only thing, if you contemplate the basics and fundamentals, whatever you are already having, and wherever required, if you are able to apply, definitely you can get the answer quickly. Okay, fine. Now the moment you got u bar plus w bar, just observe here. Here logic gates are there. You have to find out for this particular logical expression which logic gate representation is the equivalent. Okay, here you are getting OR gate, so it is not correct. U plus W you are getting, it is not correct. Here you are getting V plus X, that is also not correct. Here you are getting yes, U bar plus W bar, yes. Here option C is the correct one. Option D won't correct because here inputs are V and X. Okay, so whoever knows this logic, definitely they could have saved time like anything. But of course, whoever solved by using K-map, definitely they have got the correct answer, but you people might have invested more time, because for drawing the K-map, definitely it will take time. And after that, you are just observing in which locations you have to put zeros, and then you will be doing grouping. Okay, fine. Yeah. Next question, this is a question asked in Instrumentation 2025 regarding combination circuit, the question based on the multiplexers cascaded configuration. So now in this particular question, regarding the output function f of PQR at the second stage of the given mux. Okay, here two muxes are there at the second stage or at output stage, whatever the mux output is there. So regarding that particular expression, among the four choices, we have to choose the correct one. So just observe here. So for this question, just observe here, you are having two selection lines are there, and here number of inputs are 4. So here you are having mux inputs are 0, 1, 1, 0, for which, so it is very simple. Since you are having two selection lines, now you can consider the logic gate which is having two inputs. When you consider the input combinations like 0, 0, 0, 1, 1, 1, 1, 0, 1, 1, right, in that particular order, 0, 0, 0, 1, 1, 0, 1, 1, in that particular order when you have considered, so for which logic gate you are getting the output like this. Okay, that logical expression we have to perform among the selection lines, that's all. 0, 1, 1, 0 you will be getting for XOR gate, correct? Okay, just for reference here I am mentioning. Okay, so here the inputs are like this, I0, I1, I2, I3. Okay, so 0, 1, 1, 0 you are getting as the output for two input XOR gate. So now among these selection lines you have to perform XOR. So that means you are getting P XOR Q, right? Okay, now here you are having 2 by 1 mux. So for 2 by 1 mux, the standard equation, you are having S bar I0 plus S into I1. Here S is nothing but R. Okay. So I0 is nothing but P XOR Q plus selection line is once again R. Then here I1 equal to 1. So from here you are getting, suppose I am writing this term here, you can write any order, no problem. R plus R bar into P XOR Q. See, once again from the distributive law, whatever the distributive law we have discussed, x plus yz equal to x plus y into x plus z, by using that formula, all of you just give a try. If you are having a plus a bar b, what is the answer? I hope many of you remember by this time. See, once again the same formula, distributive law, LHS to RHS, x plus y into x plus z. So that means a plus a bar you are getting 1, so into a plus b. So that means final answer is a plus b. So regarding distributive law, LHS to RHS, RHS to LHS, and from LHS to RHS you are getting based on the distributive law only, this is one formula. Okay, now if you know this one, whatever P XOR Q you are having, you can treat like one variable. Now R plus R bar is 1, so you are getting R plus P XOR Q. Now you can choose the correct option, R plus P XOR Q. Yes, that is there in option C. See the beauty of the digital questions that they have given in this particular year in electrical, and even you can observe instrumentation. Whatever the question, in order to solve, you should have the knowledge of that particular chapter, and in order to choose the correct option, you should have the knowledge of even earlier chapter. Okay, whatever the basics are there, formulas are there, you should, like, once if you are able to remember, it's not that you have to by heart, but if you could have done good practice, definitely whatever the formulas required for solving the question, if you could have recalled very fast and if you could have applied, definitely you could have solved the digital questions in less time. Okay, right. So now we are going to solve very interesting question regarding instrumentation 2025, regarding digital circuit subject, the question from sequential circuits. This is a very interesting question. In general, if you refer regarding gate electronics or electrical or instrumentation or computer science, in many of the years, or I can say in most of the years, they used to ask regarding any particular sequence circuit, regarding with respect to normal output only, they can ask regarding the time period or regarding the frequency or whatever the initial state you are having, after applying how many clock cycles you are getting the same state, etc. So many questions. Even though connections wise, since you are having normal output and complement output, connections wise in the circuit they can connect with normal output or complement output, but always the analysis wise they will ask with respect to normal output only. But in this question, just for variety, okay, what they have asked, instead of asking for Q1, they have asked for Q1 bar. Okay, so in this particular question, they have given clock signal frequency as 12 megahertz. Okay, right. So they are asking the frequency of F. F means Q1 bar. In this particular circuit, F is nothing but Q1 bar. So for that particular F, they are asking the frequency. Now condition is what? Here in this particular circuit, you are having two logic gates, and for this OR gate, one of the input is control input. Okay. Now when that control input is 0 and when the control input is 1, okay, so that means you have to solve this question two times. Okay, when control input is 0, what is the frequency? When control input is 1, what is the frequency? Okay, so you are having the choices like this: 4, 6, 3, 6, 6, 4, 3, 4. Okay, right. See, first of all, whenever you are going to solve these kind of questions, okay, first and foremost you have to observe whether the given circuit is synchronous sequence circuit or asynchronous. Okay, so in this case it is synchronous because for both the flip-flops clock signal is same. Okay, now you can do the analysis very simple. For this particular, whatever the number of flip-flops you are having, just observe for the respective flip-flop how many inputs are there. So based on the given configuration, just represent the logical expressions, and then after applying the clock pulse, what is the state you are getting with respect to every flip-flop. Like that you can analyze, that's all, tabular form method. Okay, so first of all, here the first column is clock pulse numbering, like here in this case positive edge triggering. Okay, so regarding the positive edge triggering, we are considering here, just for reference here I am mentioning, regarding the clock signal positive edge triggering, so let us solve. We have to solve this question in two cases. Okay. Yeah. Fine. So initially just observe regarding the connections or expressions wise. So in this case, just observe D naught is nothing but Q1 bar, correct? So D naught equal to Q1 bar. Okay, for both the cases, I am writing this tabular form at the same time. Okay, D naught equal to Q1 bar. Fine. Now D1 is what? D1 is nothing but output of this AND gate. Okay, AND gate is having two inputs. One of the input is Q1 bar. Okay. One of the input is Q1 bar. Now another input is what? OR gate output. Okay. Now based on the control input, here output will vary. Okay. Let us consider in case 1 control input is 0. 0 plus Q naught is nothing but what? Q naught. So Q naught into Q1 bar. Right. Q naught into Q1 bar. I hope it is clear for everyone. See, initially you might have thought that you have to write big expression. Need not be. Not at all required. Wherever the simplification possible, do it so that you can get the answer quickly. Right. So I am repeating once again, when control input is 0, 0 plus Q naught is nothing but Q naught. Now AND gate output is Q naught into Q1 bar. Correct? Okay. Now let us analyze with respect to case 2 also. The moment you are having control input is 1, what is the output of OR gate? I hope all of you can answer easily. Yes, 1 plus anything is 1, logical. Whether Q naught value 0 or 1, irrespective of that, 1 plus anything is 1, logical. So that means you are getting 1 into Q1 bar is nothing but Q1 bar. Here you are getting Q1 bar. So in this particular case, second case, D0, D1 both are same inputs only, Q1 bar. Okay. Whereas in the first case, D0 is same Q1 bar, but D1 is Q0 into Q1 bar. Okay. Now for the first flip-flop output is Q0, second flip-flop output is Q1. Right. Accordingly I have represented, and as we have mentioned, as per the given question, F is nothing but Q1 bar. Just for reference, we have mentioned F equal to Q1 bar. Okay. So since in the question they not given initial state, you can assume 0, 0. Okay. Whenever in the question not given what is the initial state, you can assume all the flip-flop outputs are zeros. Okay. So initially I am assuming before applying the clock pulse, initially I am assuming zeros. Okay. First let us complete this case 1. After that we will discuss case 2. Fine. Okay. Now just observe. Before applying the clock pulse, we have assumed initial values are 0. Now before applying the first clock pulse, whether D0, D1 values are available or not. Before applying the first clock pulse, based on these expressions, whether D0, D1 values are available or not. Yes, those are available. Okay. So just observe here, 0 bar is nothing but 1. Next, here 0 and anything, 0. So these are the inputs already available before you are applying first time positive edge. Now regarding D flip-flop operation, you know Q of t plus 1 equal to D. That means whatever the D input you are having just before applying the corresponding positive edge of the clock signal, that particular input you are getting immediately after the respective edge of the clock signal. Right. So that means whatever here you are having, just copy as it is. Okay. Now after applying first time positive edge, you got the state like this. Now based on these values, you have to determine the inputs. Okay. So here in this case, once again 0 bar is 1. Okay. Here in this case, Q0 is 1. Okay. Next 0 bar will be 1. So 1 into 1 will be 1. I am repeating once again, Q0 value is 1. Q1 value is 0. 0 bar is 1. 1 into 1 is 1. Okay. Now second time positive edge of the clock pulse we are applying. Okay. So here in this case you are having 1, 1. Now exactly same you are getting. Now before applying the third time positive edge of the clock pulse, what will happen? Now here Q1 bar, 1 bar will be 0. Next here also 1 bar is 0, 0 and anything, 0. Now third time positive edge of the clock pulse we are applying. Now this 0, 0 will come here. 0, 0 will come here. Now what is your observation? So here you are having 0, 0 initially before applying the clock pulse. Now after applying first clock pulse, you are getting this one. After applying second clock pulse, you are getting this one. If you apply third clock pulse, you are getting the same state. That means what is the name of this particular counter? If you want to specify the mod number, can you tell? Yes, it is producing 3 unique states. Yes or no? These 3 states only will repeat. Correct? So that means it is a mod 3 counter. It is the mod 3 counter. See, whenever you are having synchronous sequence circuit, for overall circuit output frequency is same as the frequency at any particular output of any flip-flop. Say for example, since the circuit is synchronous sequence circuit, either you are considering frequency at Q0 or frequency at Q1, or for overall circuit frequency, all are one and the same. Similarly, the time periods also. Okay. So in this question, since they have asked the frequency with respect to Q1 bar, see, it is very simple. Whether they are asking the frequency with respect to normal output or complement output, the output will remain same. Okay, because see, if Q1 value is 0, in that interval Q1 bar will be 1, or if Q1 is 1, Q1 bar will be 0, vice versa. So that means if you are getting here frequency something, the same frequency here also you are going to get. There won't be any modification. Okay. So with this understanding, since you got mod 3 counter, and here the clock signal frequency is 12 megahertz, so you are going to get the output frequency the output frequency of mod 3 counter, output frequency of mod 3 counter, you are going to get f clock. F clock is 12 mega divided by number of states. So that means you are getting 4 megahertz. 4 megahertz. In this way you can answer, but if you don't know this logic, then it is very simple. Just continue one more step. Here, whatever Q1 values you got, now here you can substitute Q1 values, or you can do simple. Since you are having Q1 bar, whatever the column here you got, just complement. That's all. Here 0 will become 1, 1, and then 0, and then 1. So here also once again, if you carefully observe, these three states are repeating. Regarding f waveform, if you draw the waveform, then you are getting 1, 1, 0, 1, 1, 0. That particular pattern will repeat. So from there also you can answer once again same. Okay, so 4 megahertz you are getting. So the moment you are getting 4 megahertz for this particular question, because you are having choices like this. Okay, so directly you can choose option A. Directly you can choose option A. But suppose if two options are having same 4 megahertz, then we have to solve for other case also. Okay, for this question, the moment you got 4 megahertz, since 4 megahertz is there in only one of the option, straight away we can choose that particular option as the correct one. Suppose, because this particular question, like whatever the choices or question data, everything, it is a memory based. Suppose if you feel that, sir, no, in this particular question they have given two choices regarding with respect to case 1 they have given 4 megahertz, then we have to solve with respect to case 2, then definitely you can do. Okay, but I am giving the hint point for EC students, like whenever in the question if they ask for two cases, but with the help of first case or with the help of first case, whatever the answer you are getting, if that is there in only one of the option, without solving for other case, you can choose that option as the correct, provided with respect to first case, whatever the answer you got, that is true. You haven't done any silly mistake, then you can go ahead. But if you are having slight confusion or doubt, then definitely you have to solve for other case. Okay, right. Now here, based on initial data, you can determine the inputs here. Okay, 0 bar is 1. Here also 0 bar is 1. Right. Now first time positive to the clock pulse we are applying. Now this 1, 1 will come here. 1, 1 will come here. Right. Now, since here 1, complement is 0, similarly here. Now second time positive to the clock pulse we are applying. Now these zeros will get right shift. That's all. So now what is your observation? What is your observation? Here initially you are having 0, 0. Okay. After applying first clock pulse you are getting 1, 1. Second clock pulse, once again the same state. That means in this case it is the mod 2 counter. In this case it is a mod 2 counter. So in this case the output frequency is going to be clock signal frequency, that is 12 megahertz divided by 2. 12 mega divided by 2 is nothing but 6 megahertz. Right. 6 megahertz, that is there in option A. Okay. Of course in option B also is there 6 megahertz, but because of case 1, option A is going to be the finally correct answer. Fine. Okay. So just for reference, here also I am complementing this one, 1, 0, 1. Here also if you observe, these two states are getting repeated. So that means time period is going to be 2 times. Time period of the F waveform is going to be 2 times the clock signal time period, or frequency wise, it is the half of the clock signal frequency. Okay. So in this way, see, even though you have to solve this question by using tabular form, but you can do the while solving the question, you can save the time, provided if you could have analyzed regarding the D1 expression, because D0 expression is direct only. But regarding D1, instead of writing big expression, just case by case regarding control input when you have considered, accordingly if you write the D1 value, after that you can analyze, that's all. After that you can analyze, you will be getting the answer quickly only. It won't take much time. But only thing, when you are getting like this question, you should not solve in the first round, but you can solve this question in the second round, because it may take comparatively little more time when compared to the first round questions. Okay. So in this way you should be smart, which questions you have to attempt in the first round, which questions you have to touch in the second round, and whichever questions, if they give very typical, you can keep for round 3, or if you don't have that much time, you can leave those questions also. Okay, right. But whatever the questions so far we have discussed, I hope all of you can do it, but some of you might have took more time while solving these questions when you have appeared for IN paper or electrical paper during the actual time. So whoever going to write for EC exam, definitely these are the learnings for the EC students. That is the reason in this particular session regarding instrumentation and electrical, whichever questions asked for the digital, with respect to digital circuit point of view, I am covering each and every question. Okay, right. Yeah. Now we are going to solve the last question regarding digital circuit subject. This is the question asked in instrumentation 2025. Instrumentation 2025. So just observe this particular circuit. Just observe this particular circuit. See, you can solve this question from the digital circuit point of view. You can solve this question even from analog circuit as well, because in the digital to analog circuit, in the digital to analog converter circuit, we are using op-amp. We are using op-amp, and then here with the help of switches, we are giving like when the corresponding bit is 1, we are giving the supply input, or when the bit is 0, we can, like when we have discussed regarding digital to analog converter circuit in the classes, we used to connect if the bit value is 0, ground. But in this question, since it is a memory based question, so here in this case it is very simple. What you can consider, if the bit value is 1, we are giving the supply, or we are doing the connection to the supply. But if bit value is 0, you can keep like open. Okay, fine. So this question, you can, these kind of questions regarding digital to analog converter circuit based questions, especially when you are having the op-amp, so you can solve with respect to digital circuit point of view, or even with respect to analog circuit point of view, because regarding the calculation part, whatever you people learned in the analog circuit, that is the principles, or those are the formulas we can apply. We can apply. That's all. Okay. See the beauty of this question. Many of you might not touch this particular question during your GATE exam, but if you could have read the question, and if you could have able to recall the basics that you have learned in the analog circuit subject, damn sure you could have got the correct answer in less time. Okay, because in this question, if they ask regarding the final analog output, then that particular question, like if they have considered like whatever this part of the circuit, if you observe, like here 3K, here 6K, here 12K. So that means what? This particular circuit is nothing but binary weighted resistor type DAC, correct? So whatever the, like when we have solved the during our classes, like case 1, case 2, case 3, like that, when multiple sources, like let us consider 3 voltage sources are there, B2, B1, B0. Okay, regarding corresponding voltage sources, correct? So by using superposition theorem, we have derived the voltage expression. Like that procedure you have to do. Okay, so when you are supposed to get the output voltage. Okay, of course, since in this particular question, since they have given the corresponding binary combination, now it is completely you are having a choice. Completely you are having a choice. Even if you are having analog circuit regarding op-amp based basics, if you are having idea, then definitely you can solve this question. Definitely you can solve. Okay, so with the help of this question, at least you are getting one clue or clarity. Like when you are getting analog circuit question based on op-amp, at least you can give a try. Okay, fine. So just observe this particular question, B2, B1, B0 equal to 1, 1, 0. That means here B2 is 1 in this particular question. Okay, just for reference here I am mentioning B2 is 1, B1 is 1, and B0 equal to 0. Okay, so here B1, B2 are 1, that means here switch is closed, here also switch is closed. Okay, fine. Here B0 is 0. B0 0 means what? Here there is no close, or we can say switch is open. Okay, if switch is open, there won't be any current flow in this particular branch, correct? Okay. Now in this particular question, they have given supply voltage as 6 volt. Now what they're asking? They're asking regarding the supply voltage. Okay, with respect to supply voltage, they're asking corresponding internal resistance and the input current. Simple logic. You have to consider these 2 points. Okay, with respect to these 2 points, already supply voltage is given. So in this particular path, how much current is flowing, and then take the ratio of voltage and current. From there you are getting resistance. That's all. Okay, right. So whatever the case we have discussed here. Okay, so with that, what we can do, see, it is very simple. Like here I am considering this part of circuit. Okay, just you can observe here, just you can observe. Yeah, for the timing I am discussing here only. Yeah. So just observe here, to the positive terminal, here we, as per the given circuit, ground is there. Okay, so that means the same ground here also will come. Ground means what? 0 volt. Here physically you have connected with one wire. Okay, you have connected non-inverting terminal to ground, but here physically we haven't connected, but virtually short is happening. Virtually short is happening. Now, with respect to this particular case, okay, here we have to calculate I in and then we have to calculate R in. That's all. Fine. So here already the switch is open, so that means there is no current flows in this particular branch. You can neglect this particular branch. Okay. Now here the switch is closed. Okay, just for reference here I am mentioning the switch is closed. Here also the switch is closed because B1, B2 are 1. Okay, now just observe. Now just observe. Here 6 kilo ohm resistor is there. One side you are having 0 volt. Okay, another side you are having 6 volt. Another side you are having 6 volt. Now it is very simple. Whenever you are having a resistor, one side you are having 0 volt, other side 6 volt. Now by using Ohm's law, 6 minus 0, that is nothing but 6. 6 divided by 6. Okay, so 6 divided by 6k. 6 divided by 6k, that means 1 milliampere. 1 milliampere, that's all. Similarly, in this particular branch, how much current is flowing? Once again, 6 minus 0, that is 6 divided by 3k. So 6 by 3 is nothing but 2. 1 by k is nothing but milli. Okay, so now just observe, in this particular branch there is no current flows. Okay, in this branch 1 milliampere, in this branch 2 milliampere. That's all. That's all. So now you can apply KCL at this particular node. Now you can apply KCL at this particular node. Here IN is entering, whereas in these 3 branches currents are leaving. Anyway, here 0 ampere. Now just observe, 1 milli, 2 milli, both are leaving. So together 3 milliampere is leaving. So that means IN is nothing but 3 milliampere. IN equal to 3 milliampere. Okay, now you are having V in, you are having I in, so that means we can calculate R in, voltage divided by current. So voltage given as 6 volt, current given as 3 milli. So 6 by 3 is nothing but 2, 1 by milli is nothing but kilo. So units are ohms, so 2 kilo. See the beauty of this question. See the beauty of this question. If you know the fundamentals, see, when you are getting like this question, understanding the given data, understanding the question only, it may take time. But once if you catch what they have given, what you are supposed to calculate, now fundamentals if you are able to apply from network theory subject or from analog circuit subject, definitely you can solve it. Definitely you can solve in less time. See, that is the most important. That is the most important. Some students might be thinking that, so when I told that you can solve it, it's not that you have to solve in more time. No. Because in the given time, in the GATE exam, you are having 3 hours time. In the limited 3 hours time, whichever questions possible for you, like easy category and moderate category, definitely you should try your level best to maximize your score in the GATE exam. Okay, but if you are taking more time for easy questions and moderate questions, definitely the given time may not be sufficient for you people. Okay. So I hope all of you got to know whatever the questions which are asked regarding digital circuit subject with respect to instrumentation paper and electrical paper as well. Okay, we have discussed all the questions, okay, regarding digital circuit subject point of view. I hope whoever attempted these questions now, you could have cross-checked whether your answer is correct or not. At least data wise, if something here and there change is there, at least the procedure whatever we have discussed, with the help of, if you followed similar procedure or even with the different method, but definitely whatever the method you followed or procedure you followed, but if you done, if you followed correctly, definitely your answer is right. There won't be any doubt in it. Okay, so whatever the questions here we have discussed, definitely these questions and solutions whatever we have discussed, definitely it is going to help for the GATE 2025 EC students. Okay, all of you kindly like and share this video link with maximum number of your students, with maximum number of your friends. So definitely each and every student whoever going to write, GATE 2025 EC paper, definitely every student can maximize their score regarding digital circuit subject. Okay, and whatever the basics we have covered with respect to op-amp, definitely it is going to give value addition with respect to analog circuit subject as well, because in the instrumentation paper and electrical paper, in both the papers, 2 questions given based on op-amps. One question they have given like simple question, easy question we can say. Another question they have framed based on like 2 op-amps or op-amp based circuit they have given, and they asked some parameter to calculate. Okay, right. Yeah. So that's all in this particular session. I hope all of you got maximum benefit from this particular session. As I mentioned earlier, so whoever not yet joined our Telegram channel, all of you kindly join our Telegram channel regarding the link already provided in the description of this particular video. Okay. Yeah, that's all in this particular session. We'll meet you all in one of the upcoming session. So thank you everyone.